So this is the FACIT 1118J early calculator. The VFD display is quite big, and the calculator itself it's massive, so it's more than a palm wide. It's very thick and not light, metal parts inside and so on. Has a beautiful layout and color scheme, and the VFD, it's hard to display on a video, but in the pictures you can see that it has this multi-tone of green even when it's off, because each one of the characters is an individual tube there, so it's quite nice. So let's check if everything is working. All the digits are working as they should. And you see the space between the numbers and this is because there's a individual element for each one of them. And also the fact that they are not incredibly well aligned, again, because each one of them is placed separately. So it's impossible to keep them in line. So a very early calculator. The keys are all working as we would expect. This is with 0 decimal places, so if we divide 10 by 3, we have 3 only, and there's a sign there. If we have 10, let's put it in 1 decimal place, 2, 2 decimal places, 3 decimal places, 4, and 6. And it doesn't have a float, it doesn't go all the way to use all the digits. Has a rounding function here. So rounding down, so 5.9 divided by 2. You're rounding down, it's going to be 2.9, and 5.9 divided by 2, rounding up, it's going to give you 3, depending on the rounding that you select, and of course the number that you are dividing or not. So all the keys working, the different decimal number of characters is working as well, rounding is working. Basic operations, so let's clear it all. 3 plus 6, 9. 5 minus, again, in the format that you would have in old mechanical calculators. So you type the number and then the operation, and then we subtracted the 2 numbers. Multiplication works as well, so all the operations work as they were expected. Then you have here the constant, so 2 times 3, 6. And then adds the 2, and then adds the 6, and then adds the 6, and then adds the 6. While if we turn on the constant, so let's clear constant, and then the first number is going to be recorded in memory, so 2 times 3, and the 2 is the constant, so now when we press equal, it's going to multiply by 2, which is the constant, and the calculator behaves differently as the constant was expected to do, which is particularly useful for exponentials. So if you're doing exponential, so let's suppose 1.04 times 1.04, and the memory, the constant is activated, so to the power of 2, to the power of 3, 4, 5, 6, 7, and so on. So it's a way to do exponential in a simpler way without the exponential key. We have here what we would say that's a memory function with an I, which is quite curious. So let's suppose 2 add to the memory, and then you have this I over there, and 3 add to the memory. So these 2 numbers, 3 and 2, are in the memory now added. If we clear and we recall the memory, it's 5. And if we clear the memory, it's the I disappears and there's nothing in the memory anymore. So old calculator, in a sense that even the convention of using M for memory was not yet established at the time that this calculator was produced, or for the market it was produced. And then you have the RV here, which is a recall value. So if you're multiplying 2 by 3 and you want to know what is the value that you entered before, you can recall this value and know that it's 2. And by this you come back to the one that you're using, and then you can press the equal and the button equal and do the calculation. This option not only recall the value but swaps the value from the display to the memory. So let's suppose that you have 10 divided by 3, that's 3.33. But if we do 10 divided by 3 and we recall the value, we swap the memory with the display. So now we have 3 divided by 10, which is 0.3. So it has the two functions of recalling the number that you had before, and also the idea of swapping the display and the register. Very curious that it has this thing here, which is useful if you're doing calculation with money and you're changing to different decimal place. So let's suppose I have 2 decimal places here. Let's suppose that we are adding up a couple of values, all money and all with cents and so on. And this number, this mechanical thing, this plastic element that slides, can tell you that these are the cents, this is the thousand separator, and this is the million separator. So if we do a few more times, so there you have 10,685 and 7 cents. So curious way to display the thousands and millions without having to program that and implement something in the display itself. So a calculator full of particular elements and very curious for the time. Even this one that later on was called exchange, EX, or something in this range, that you don't have float, even though you could have float here, nomenclature. And the color scheme, the calculator is really, really beautiful. This particular one belonged to Richard John, and the name of the previous owners is still here. I think it's a nice feature to keep it for posterity and for future generations that will probably not be tagging their calculators as a precious element that needs to be properly labeled, and certainly quite expensive at the time it was bought, and a dear possession. So this is the FACIT 1118J with a nice VDF, with a nice VFD display, and in all its functionalities. So this is the FACIT 1118J in all its functionalities.